I'm Anil Kumar. Welcome to my series in providing you the solutions for GCE test papers. Now, this time we have taken up June 2018 test paper, advanced level. In part A, we have shown solutions from question number 1 to 10, and in part B, we'll provide you solutions of the other questions. Here is question number 11. It has 3 parts and is based on binomial expressions. Part A is, use binomial expressions to show that square root of 1 plus 4x divided by 1 minus x is approximately equal to 1 plus 5 over 2x minus 5 over 8x squared. A student substitutes x equals to half into both sides of the approximation shown in part A in an attempt to find the approximation to square root 6. Give a reason why students should not use x equals to half. Part C is, substitute x equals to 1 over 11 into this expression to obtain an approximation to square root 6. Give your answer as a fraction in its simplest form. Now, we need to use binomial expansion. Now, normally, binomial expansion is only used when n is greater than 1. However, for such exponents, the rational exponents, we can actually use binomial expression provided that the value of x inside is much smaller. That is to say, we could use this expression 1 plus x to the power of k as equal to 1 plus kx plus k times k minus 1 over 2 factorial times x squared plus k times k minus 1 times k minus 2 over 3 factorial times x cubed and so on. And that is only possible when absolute value of x is very small as compared to 1. So only then we can use this expansion. So the reason why a student should not use half, since half is not very small as compared to 1, right? It could be like 0.1 or lower. So when we substitute x equals to 1 over 11, it is less than 0.1, so it works. You get the idea, right? So that is the answer for the other 2 questions. Now, let us try to use binomial expansion, this one, to show that this is equal to that, right? Let's try to prove this using this particular formula now, right? So let's take numerator and denominator separately. So first we'll expand 1 plus 4x to the power of half, right? So using this particular formula. And then we'll do the denominator part and then we'll work out both together, right? So 1 plus 4x to the power of half, we are using this particular formula, 1 plus kx, that means 1 plus k is the exponent. So it is half and x is 4x for us. Is that clear, right? Plus k times k minus 1, that is half times half minus 1 over 2 factorial times x squared will be 4x whole square, plus the other terms are very small, so we can just neglect them. Is that clear to you? Right? Now let's simplify this. So what we get here is 1 plus, this is 2x, plus half times, let's write this, half times minus half, right? This is 1 over 2 factorial is 1 over 2, and that gives you 16x squared, right? So we are neglecting the other terms. Since x is 4x is very small, right? So in this case, we're neglecting the other terms. So that gives you 1 plus 2x plus, now actually it becomes minus because of this minus. 2 times 2 times 2 is 8. 16 divided by 8 will give you 2x squared. Perfect. So that becomes the numerator part. Now let's expand the denominator, which is 1 minus x to the power of minus half, right? So we could write this as 1 minus x to the power of minus half. Basically, it could be written as, the left side could be written as 1 plus 4x to the power of half times 1 minus x to the power of minus half. Clear? So we are expanding them one by one, and then we are going to multiply them. Right? So it is 1 plus, okay, let's write like this. This is minus half, so we'll have minus half times whatever is inside, which is minus x, right? Plus the exponent, which is minus half, times minus half minus 1 over 2 factorial, and here we get minus x whole square. We are going to neglect the other terms, right? So that gives you 1 plus x over 2, half of x, and that is this becomes positive. Now in this case, let's write down minus, this is also minus, so that will make it positive. So we have half minus and minus, let me write this as 3 by 2. 1 over 2 factorial is 1 over 2, and that becomes positive, right? X squared. Is it clear? So that is what we are going to get here. So let's write down this as equal to 1 plus x over 2. And here we have 1, 2, 3, that is 8. So plus 3 over 8 x squared, right? So we get this expression as 1 plus half x plus 3 by 8 x squared. Now multiply these two to get our expression, which is basically 1 plus 4x to the power of half times 1 minus x to the power of minus half, correct? So this is these two terms you have to multiply. 1 plus 2x minus 2x squared, multiply with this term, which is 1 plus x over 2 plus 3 over 8 x squared, approximately. Right? Now you have to multiply each term. So with 1, when I multiply all this, I get 1 plus x by 2 plus 3 by 8 x squared. Now I'll multiply with 2x, so we get plus 2x. This term we get plus 2 and 2 cancel, we get x squared. Now all those terms which involve higher order, more than its square, will be neglected. So we're neglecting the other term, right? So approximately minus 2x squared, and when you multiply with this, you get x cubed. So we are actually excluding that also, right? So we are excluding those terms, right? So now let's reorganize and combine these terms. So what we get here is 1. As far as the x coefficients are concerned, we have x by 2 plus 2 by plus 2x. Okay, let's write them together. We get x by 2 plus 2x. Now for the x squared, we have 3 by 8 minus 2 times x squared, right? Okay, so that gives you 1. 4 plus 1 is 5, so we get 5x by 2 plus 8 times 2 is 16, and when you take away 8 times 2 is 16. We missed this x squared, right? So minus 2x squared plus 2x squared will only get 1 here, right? Sorry. Since we have these two terms to be combined, right? X squared minus 2x squared will be 1x squared. Okay, so let's do this correction and move forward. So 8 minus 8 times 1 is 8. So we get minus 5 over 8. As expected, x squared. So let me rewrite this, which is 1 plus 5x by 2 minus 5 over 8 x squared. Okay? So that is what we wanted to show. Is that clear to you, right? So this is what we wanted to show, and that's what we have got. So that is how you can use the expansion and get your solution. So I hope these steps are absolutely clear, right? Now here it is, as we said, x has to be very, very less as compared to 1, right? So we expect x to be less than 0.1. So that is why this is not valid. Now 1 over 11 is quite valid. So let's use part C to find, let's use 1 over 11 to find the value of square root of 6, right? So we'll substitute 1 over 11 in our expression. So what we get here is 1 plus 4 times 1 over 11 divided by 1 minus 1 over 11, right? So we're substituting x equals to 1 over 11. So let me write here. Push the page a bit. So we'll substitute x equals to 1 over 11 and calculate the value. On the right side, we have 1 plus 5 over 2 times 1 over 11 minus 5 over 8 times 1 over 11 whole square. Clear? So here we get square root of 11 times 1 is 11 plus 4 over 11 divided by 11 minus 1 over 11, right? Equals 2. Here we get 1 plus 5 over 22. Here we have 5 over 8 times 121. Okay. 11 plus 4 is 15. Over this 11 cancel. 11 minus 1 is 10. So we get square root of 15 over 10. Now let's try to figure this out here. So 15 over 10 is basically 5 over 2, right? So this could be written as dividing by 5, we get 3 over 2 square root. Now since we need square root of 6, we need to approximate square root of 6. So to get square root of 6 here, I should multiply by square root of 2, right? So I should multiply this by square root of 2 over square root of 2. And that will give me square root of 6 over 2. Is that clear? So we have left hand side, we have written like this. Correct? Now, let's look into the right hand side, right? Which is this expression separately. Since we have less space here, so I'm just trying to squeeze it in. So what we get here is 8 times 121, that, and we have to do all this. Let's use the calculator. So we have 1 plus 5 divided by 22, and to this we'll take away 5 divided by, within brackets, 8 times 121. So that gives you 1183 over 968. Clear? So that is what we get on the right side. Perfect. So from here we can now write down that square root of 6 over 2 is equals to 1183 over 968, or square root of 6 is equals to 2 times, right? 2 times 1183 over 968, which is, we'll just multiply this by 2, and we get this as 1183 over 484. Clear? So that is the value of square root of 6. So we get our solution for square root of 6 as, let me write down here clearly, square root of 6 is basically equal to 1183 over 484. Clear? So let me explain what I did. We didn't want to run into the next page, which is actually provided for this solution. we kind of simplified the left side separately. We got square root of 3 over 2. To make it square root 6, I multiplied and divided by square root 2. Basically rationalize, right? So we got square root 6 over 2 on the left side. On the right side, we use our calculator to find the value and then figure out the value of square root of 6. So I hope the steps are absolutely clear. Here is question number 12. The value in pounds for pounds V of a vintage car T years after it was first valued on 1st January 2001 is modeled by the equation V equals to AP to the power of T, where A and P are constants. Given that the value of car was 32,000 pounds on 1st January 2005 and 50,000 pounds on 1st January 2012, find P to 4 decimal places. Show that A is approximately 24,800. Part B is, with reference to the model, interpret the value of the constant A, the value of the constant P. Using the model, part C is, find the year during which the value of the car first exceeds 100,000 pounds, right? So this is fairly straightforward. Let's try to substitute the values given to us and find the solutions to 4 decimal places for P first. So this formula is valid from January 2001, and on 1st January 2005, the evaluation was 32,000. So 2005 minus 2001 is 4 years, right? So from this given information, we can write T equals to 2005 minus 2001, which is 4. Substituting 4 here for T, the value given to us, we get one equation, and this equation will be 32,000 equals to the amount, which is A, and then we have P to the power of 4, right? Now the second equation is 50,000 for 2012. So 2012 minus 21 will give us 2001 is 11, right? So here T is equal to 11, correct? So we'll use the second equation, T equals to 11, to get the second equation. The value is 50,000. So we have 50,000 equals to AP to the power of 11. Let's call these as our equation number 1 and equation number 2. So if I divide one by the other, let's do equation 2 divided by equation 1. So we get 50,000 divided by 32,000 equals to A and A cancel, right? So we get, let me rewrite and then we'll cancel. P to the power 11 over A, P to the power of 5. So let's simplify. The right side for us is 50 divided by 32, which is 25 over 16. A and A cancel. P to the power of 11 minus 5, which is 6 for us, right? So we get this as sorry, this is not 5 but 4. Okay. 11 minus 4, which is 7 for us. So we get P to the power of 7. So from here we can find the value of P. So P will be equal to 7th root of 25 over 16. Clear? So let's find the power as 1 divided by 7. So that gives you a value which is equal to 1.06583. So we get a value of P which is 1.06583. Now find P to 4 decimal places. So we are going to write to 4 decimal places. So the value of P will be equal to 1.0658. So So that is what it is. So normally the solutions will be provided in this space. However, since I want to keep focus on the questions in all my solutions, I have shown you solutions at the most convenient place to explain the idea, right? Okay. Now once we find the value of p, we can also find the value of a. So you can use any one of these equations. We can say a is equal to first equation, 32,000 divided by the value of p, which is 1.0658 to the power of 4. Okay. So what we get here is 32,000 divided by, within brackets, 1.0658 to the power of 4, which is 24,799, right? So this can be, as written here, approximated to 24,800 pounds. Okay? So we have shown that A is approximately equal to 24,800 pounds. Okay. Now, with reference to the model, interpret the value of constant A and the value of constant P. Now, clearly, from this, A is what? If you read the very first sentence, it says the value V of the vintage car T years after it was first evaluated on 1st of January 2001 is modeled by this equation. So the value of A is actually the value, I can say, on 1st January 2001, correct? That is what it is. And P is the rate at which it is growing, right? So growth rate. So the value of P, which is equal to 1.0658, indicates that there is 6.58%, you can say, growth or appreciation per year since 2001. You can say January 2000. Is that clear to you, right? So that is how we can interpret the values of A and P. Okay. Now let's look into part C, which is find the year during which the value of the car first exceeds 100,000, right? So let's use the value which we got. We'll approximate to 24,800. So we'll use the formula now we want this final amount to be, we'll use the formula, this A is 24,800 and the value of P is 1.0658 and the power will be T, right? Now we want to find the year when it exceeds 100,000 for the first time. So let's substitute 100,000 here for V, and then we'll find what T is. Correct? So it'll be 100,000 divided by 24,800 equals to 1.0658 to the power of T. So let's calculate how much this is. So we have 100,000 divided by 24,800. That is 121 over 31. So we get this as 125 over 31. Now that's what we get, right? You can also write the decimal value for this, which is, well, we'll use this 125 over 31 since that's a recurring value. Okay. Now how do we solve this? To solve this equation, we should take log both sides. So we'll take log both sides. We say T log of 1.0658 equals to log of 125 by 31. So that gives you the value of T as equal to log of 125 over 31 divided by log of 1.0658, right? Okay. So let's do this. We have log. You can use log or ln. Divide by 31. And then we'll divide this by log of 1.0658. That gives you 21.88. That means the value of t is more than 21, right? So it is. So here is question number 13 from advanced level paper, Pure Mathematics, June 2018. The question here is to show that the integral 0 to 2 of 2x square root x plus 2 dx is 32 over 15, 2 plus square root 2. You can always pause the video, answer the question, and then look into my suggestions. Now in this integration, we have product of two functions. Since we have product of two functions, we could do integration by parts, right? Now the general formula for integration part is that if these functions are written as integral of u dv, in that case the integral will be product of u and v minus integral of v du. So basically we need to decide what to take as u and what to take as dv. So let's write u equals to 2x and dv equals to square root of x plus 2. So if we differentiate this, we get du equals to 2 dx, and if we integrate this, we get v equals to x plus 2 to the power of, this is half, plus 1 will be 3 over 2, and we get here 2 over 3, right? So the solution will be integral of from 0 to 2 of 2x square root of x plus 2 dx. As you can see here, we took 2x as u and this as dv, right? Correct? So I should have written, sorry. So we will write this 2x dx, right? So integral will be this. So that part is dv. So the solution will be product of these two, right? uv, product of these two, take away integral of these two, correct? So we'll multiply these two. So we get 2 over 3 times 2x times x plus 2 to the power of 3 by 2 minus integral of product of these two, right? So product of these two will be 2 times 2 over 3 x plus 2 to the power of 3 by 2 dx. Correct? So that is how we get our solution, and now we need to integrate this from 0 to 2. Sorry, this 0 to 2 is for the whole thing, this whole solution. Okay. Now let's simplify this. What we get here is 2 times 2 is 4, 4 over 3x, x plus 2 to the power of 3 by 2 minus, here we get 4 over 3 times integral of this. When we add 1, 2 times 1 is 2, 2 plus 3 is 5, so we get 5 over 2. So here we'll write 5 over 2, and this power will be x plus 2 to the power of 5 over 2, right? So all this from 0 to 2. Okay? So that becomes the definite integral. Now we can substitute 2 for and 0 and get our solution. We need to show that this solution is 32 over 15 within brackets 2 plus square root 2. So when you substitute 2, here you get 4 over 3 times 2 2 plus 2 to the power of 3 over 2 minus, let me write this as 8 over 15, 2 plus 2 to the power of 5 over 2 minus, now you substitute 0 here, the first term is 0, and when you substitute 0 here, this minus and minus becomes plus, and you get 8 over 15, 2 to the power of 5 over 2, right. Now that is 4 over 3 times 2 times 4 to the power of 3 over 2 minus 8 over 15 times 4 to the power of 5 over 2 plus 8 over 15, 2 to the power of 5 over 2. 4 square root is 2. This term will be 4 over 3 times 2. Square root of 4 is 2 and cube is 8. So we get 8 here. These two terms, 8 over 15, 2 to the power of 5 is 32. Okay. Plus here we have is it could be written as 8 over 15 times, you could write this as 4, right? 4 plus 1, so 2.5, right? So it is 2 square times square root of 2. Okay. That is 5 over 2, right? So you could write like this. So let's simplify this further, which we get 8 times 8, 64 over 3 minus, let's use calculator, 8 times 32, 256 over 15 plus 4 times 8, 32 over 15 square root 2. Now we can calculate this side, which is, you can take common denominator of 15 and then solve. 5 times 64 is 320 minus 256 plus, we do have 32 over 15, so I'm just keeping that as such, square root of 2, right? So that term is fine. So let's calculate this, which is 320 minus 256 divided by 15 is equal to 64 over 15 plus 32 over 15 square root of 2, correct? So some steps are required here to do, but finally we do get 32 over 15 as common, right? So taking 32 over 15 common, that is 2 times the 64 plus square root 2, we do get the result which is required, right? So that is how you could answer this question, right? So I hope these steps are okay. There is some work to be done in this area, but anyway, so by combining these terms and understanding that square root of 4 is 2 helps us to simplify and get our solution faster. I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best. Last question of the series, question number 14. A curve C has parametric equation x equals to 3 plus 2 sine t, y equals to 4 plus 2 cos t, where t is between 0, t is greater than or equal to 0, less than 2 pi. Show that all points on C satisfies y equals to 6 minus x minus 3 whole square. So that's 2 marks. B. Sketch the curve C. 2. Explain briefly why C does not include all points of this particular curve where x belongs to real numbers. The line with the equation x plus y equals to k where k is a constant, intersects C at two distinct points. State the range of the value of k, writing your answer in set notation. That's a very beautiful question. Let's see how to solve it. Now, normally you have to solve in this space. Now, what we are going to do is try to use the space in between also, and do it in the shortest possible way. So let's in the very beginning understand how to show that all points on C satisfy this particular condition. Now we are given x as 3 plus 2 sine t. If I substitute this for x, let us see what do we get for y. Do we get this equation? If we get that, then that means these points satisfy the given condition, right? So what we will do here is we'll substitute x as 3 plus 2 sine t, right? So we can write here 6 minus, instead of x, I'm writing 3 plus 2 sine t. And here we have minus 3 whole square. Now 3 minus 3 is 0. So what we get here is 6 minus 2 sine t whole square, which is equal to 6 minus, now square of this is 4, sine square t. Now we can apply the formula that cos 2t is equal to 1 minus 2 sine square t, right? So we have a formula which we can use here, that is cos 2t can be written as 1 minus 2 sine square t, right? So that basically means that 2 sine square t can be written as 1 minus cos 2t, correct? So we'll substitute 2 sine square t with 1 minus cos 2t. So this could be written as equal to 6 minus 2 times 2 sine square t, right? So now I'll substitute 2 sine square t as 1 minus cos 2t. 2 times 1 minus cos 2t. So when you open the bracket, you get 6 minus 2, and minus minus becomes plus 2 cos 2t. 6 minus 2 is 4, so we get this as 4 plus 2 cos 2t, correct? So we do get the equation y equals to 4 plus 2 cos 2t. So that clearly indicates that the equation represents the given condition, right? So all the points on C will definitely be the points on this, correct? Now, part B is sketch the curve C. And we also have here explained briefly why C does not include all the points of this curve where x belongs to real numbers. So actually, let's begin with B, part 2. Let's explain why all the points are not there on this particular condition. Now, for y equals to x minus y equals 6 minus x minus 3 whole square, it's a parabola, right? This is a parabola which opens downwards with a vertex at 3, 6, right? X belongs to all real numbers, right? However, we have a restriction on x and y here. Let's see that. We are given t, anyway, it's a periodic function. So as far as sine t is concerned, for sine t, the maximum value can only be between plus and minus 1, right? So for sine t, the maximum value is between plus and minus 1. So if I substitute that value here, right, then the value of x will be in between what? 3 plus 2 times minus 1 and 3 plus 2 times plus 1. correct? Since x is 3 plus 2 times sine t. So that gives you 3 minus 2 as 1, and this gives you the value as 3 plus 2 as 5. So x is restricted between 1 and 5, both included. Perfect. Similarly, the value of cosine, cos of 2t, is also restricted between minus 1 and plus 1. And therefore, y will be between 4 plus 2 times minus 1 or 4 plus 2 times plus 1, right? So that means the value of y is between 4 minus 2, which is 2, and 4 plus 2, which is 6. So the domain and range for the given parametric equation is restricted. So we can write here domain and range for C, curve C, is restricted as shown above. Right? It is definitely not x belongs to all real numbers. All real numbers, right? So it is the one which is shown here. So that is why all the points on this curve are not included, right? So the only points included are for x, which is between 1 and 5, right? Where x belongs to real numbers, of course, where x belongs to real numbers, correct? So that is how we could explain, right? Now let's see how to sketch the curve C. So curve C is a restricted parabola. So we have a maximum and we got these two limits. So now we'll sketch the curve. So we have this equation, which is y equals to 6 minus x minus 3 whole square, and we know that the value of x is between 1 and 5. Good. So if I substitute 1 here, so for x equals to 1, y equals to 6 minus 1 minus 3 whole square, which is 2 square is 4, so 6 minus 4, which is 2. And for x equals to 5, y equals to 6 minus 5 minus 3 whole square, which is 6 minus 2 square is 4, which is again 2. So the 2 points which are on the extreme are, this point is 1, 2, the other one is 5, 2, correct? And from the curve, we have a maximum at the vertex, which is 3, 6, right? So the parabola, which we are trying to sketch here, is like this, where this point here is the vertex given by the equation 3.36, correct? And these 2 points are included, and these 2 points are 1, 2, and 5, 2. Clear? So that becomes the sketch of our parabola. Okay, let me just make this. So that is x and this is y. Okay, now we need to state, okay, so we are done with this part. Now we have another part to this question, which says the line with the equation x plus y equals to k, where k is a constant, intersects C at 2 distinct points. State the range of the values of k. Now, for part C, let's move. So for part C, we are given the line x plus y equals to k is tangent, right? Now in this line, slope is m equals to minus 1, correct? So we could write this as y equals to minus x plus k. So the slope is minus 1. So if I draw a line with slope minus 1 on our graph, what do we get? So all these colored pens which I am using is for explanation purpose. So we may have a line which goes like this, and on the other extreme we may have a line which goes through this point, right? So say state the range of values of k. Now the important point here was the line with this equation where k is a constant intersects c at two distinct points. So if it is going through this, it intersects only at one point. So any line which is in between, not this one, but including this one, intersects at 2 points, right? So that decides the value of k. Perfect? So we need to find the value of k for these two. Okay. So we know one limit. The lower limit is when the line goes through 0.52. So if I substitute 5 and 2, what do I get? So 1.52 gives us one limit. So for 5, 2, if I write x is 5 plus 2, we get the value of k as 7. So the lower limit, or you may say the higher limit, whatever one of these limits, is k equals to 7, correct? Let's find the other limit. So we need to find the point of intersection. So we need to find this point of intersection between this. So how do we find that? Okay. So the concept is that from the equation we can find the derivative, and that should give us the slope of the tangent. So the concept is that the derivative equals to slope, right? So we have the function as y equals to 6 minus x minus 3 whole square. So dy dx is, that is 0 minus 2 times x minus 3. Now we want this derivative to be equal to minus 1, which is the slope. Now from here we can find the value of x. So dividing by 2 minus 2, we get x minus 3 equals to minus 1 divided by minus 2, which is half. So the value of x is half plus 3, which is 3 times 2, 6 plus 1, 7 over 2, right? So the value of x is 7 over 2. We can now find the value of y for 7 over 2. So y equals to 6 minus 7 over 2 minus 3 whole square, which is 6 minus, so that gives you 3 times 2 is 6, so half whole square, which is 6 minus 1 over 4, or 24, 6 times 4, 24 minus 1, which is 23 over 4, right? So y value is 23 over 4. So we get x and y value of this coordinate point as 7 over 2 and 23 over 4, correct? So we know x plus y is equal to k. So x for us is 7 over 2 plus y is 23 over 4. And when you add them, common denominator 4, we get 14 plus 23, which is 37 over 4. Correct? So that is the value of k. So this value of k is 37 over 4, right? So 4 times 7 is 28, much higher. So we find our answer that k should be greater than equal to the value of 7, but should be less than 37 over 4, correct? Since at 37 over 4, you get only one point of intersection. So that gives you 2 points of intersection. Is that clear, right? So that is how we are going to solve this question. Extremely difficult question, and it involves a lot of techniques. So I hope the solution and the concept is absolutely clear. So with that, we come to an end of this particular test paper. All the questions have been solved. You can look into the solution of other questions in this playlist. And if you have any concerns or doubts or similar questions for help, you can always send me an email on the address given here. Feel free to write your comment, share my videos, and if you like and subscribe to them, that'd be great. Thanks for watching and all the best.